Good morning, everybody. I hope that you got on okay with the shape work that we did yesterday. We're going to be doing a little bit more of that today. The first thing that I would like you to do, though, is to follow the BBC Bite-Size link that I've put onto your webpage. What I'd like you to do is watch the small video. It's only about a minute long and it just talks about classifying triangles, and there are some different activities for you to do on there. Once you've done that, you can come back to this video and we're going to be looking in more detail at quadrilaterals today, and I'm going to show you a new way of sorting different shapes. So go and do your triangles learning first and then come back to me, please. Okay, so you should by now be very familiar with the different types of triangles. Now I've got 4 different triangles on my screen that I'm sharing with you now. Can you remember what the names for all of these triangles are? The green triangle is probably the easiest one for us to identify. Now it's got 3 sides. All of those sides are the same length, and all of the angles within that triangle are the same. They are all equal. So it's an equilateral triangle. The red triangle has got 2 sides that are the same length and one side at the very bottom that is a little bit smaller. So that one there is an isosceles triangle. It has 2 sides that are the same, 2 angles that are the same, and one that is different, one that is pink. This triangle has got 3 sides that are all different lengths and 3 angles that look like they are different sizes. So it can't be an equilateral triangle. It can't be an isosceles triangle. It is a scalene triangle, but this one is a special type of scalene triangle. Can you see that at the bottom, right there, would be a right angle? Therefore, as well as being a scalene triangle, we would call this one a right angled triangle. So well done at home if you said that the pink triangle was a right angled triangle. You are absolutely right. The second triangle is actually very similar to the first, except for here we don't have a right angle. This one is slightly bigger than a right angle. That's actually an obtuse angle. But they're similar in that all of the other angles are different and all of the lengths of the sides are different. Therefore, that one is also a scalene triangle, but not a right angled triangle, just a scalene triangle. Well done if you correctly identified all of those different types of triangles at home. Moving on to sorting our triangles using a Venn diagram. I've got 4 triangles again. We've got A, B, C, and D. Now, in the Venn diagram, I've got my 2 circles. On the left-hand side, we've got isosceles triangles. Now, isosceles triangles are triangles that have 2 equal sides and one that is different. And then I've got on the right-hand side, right-angled triangles. Now, they can be scalene, they can be isosceles, but they have to have one corner, one vertex that is 90 degrees. So let's look at A first. A is the purple triangle. Can you see there? It's got 2 sides that are equal and one that is different. No angles there look like they are a right angle or a 90-degree angle. So A would need to go into the isosceles hoop, but not into the bit that overlaps. There we go. Well done if you agree with me and you'd already figured that out. Moving on to B. Now, B is definitely not an equilateral triangle. It's not an isosceles triangle because all of the sides are different, but it has that right angle in the bottom left-hand corner. So it's not an isosceles triangle, but it is a right angled triangle. We will put it into the hoop that is on the right. There we go. Now, C has got a right angle, so I know it definitely is a right angled triangle, but 2 of those sides also look like they are the same length to me. If you just tilt your head ever so slightly, the line that is vertical and the line that is horizontal, they look about the same length. Now, it's quite often difficult to see on the computer screen, but I think that is an isosceles triangle as well as being a right angled triangle. So I'm going to put that one in the middle. And then D is also an isosceles triangle. You can see the two sides of the triangle are the same. The line that goes horizontally is longer. So 2 sides are the same. So it is definitely isosceles. Tilting my head, I don't think that is a right angle. So I'm going to put D into the isosceles triangles over there. Well done if you agreed with me at home. Again, if you're not 100% confident with this, then please don't worry. There's plenty of resources that I can direct you to. If you think that you need a bit of extra help and you've already been on the BBC Bite Size website, then just drop either Mr. Mac or myself an email. We can get some extra work sent over to you, no problem at all. Otherwise, if you're feeling confident with your different types of triangles, going to be moving on to doing some more organizing and sorting of different 2D shapes, but we're going to focus a little bit more on quadrilaterals today. I also have two brand new pieces of vocabulary that we're going to introduce, and they both begin with the letter P. They are words that you may well have come across before, but you might not have done, in which case you need to be listening really carefully to make sure that you understand these two new important pieces of vocabulary. Here we go. So the first one that we're going to have a look at is parallel lines. Now, parallel lines are either two sides of a shape or two independent lines. If they are parallel, they remain the same distance from each other and they will never touch or cross over. So the best way really of thinking about parallel lines is to imagine train tracks. If you imagine you've got your train tracks that the train runs on, when one turns slightly to the side, the other one moves at the same time, so that those train tracks never get closer together, but they also never get further apart. Otherwise, it would be a disaster for that train. So parallel lines are the same distance from each other and they travel in the same direction. Another easy way to remember that this is what parallel means is if you look at the word parallel, there are two L's down the middle of the word parallel, and those two L's are parallel to each other. Now, lines might look like they're parallel, but they could be ever so slightly off. So sometimes it's really difficult to work out whether in a shape you have parallel sides or not. So there's an easy way to recognize or to label to show somebody that those two sides are parallel. They're equally distant from each other all the way along. They never get closer together. They never get further away. Now, if you look here, I've got a quadrilateral on the screen for you. Can you see there's a blue line at the top and the bottom horizontal lines? That pair of blue lines show you that those two sides of that shape are parallel. That shape could be extended forever, and those lines will never get any closer. They'll never get further away. They will never touch each other or cross. Now, sometimes this might also be shown as an arrow. So if you look at the second example in pink, I've drawn two small arrows. I've just zoomed in to show you a little more clearly what I'm referring to. In this PowerPoint and in some of the worksheets from Twinkl, you'll see the blue lines that will represent that the two sides are parallel. But actually, moving forwards and as you go through school and through secondary school, it's the ones below that I've added into the PowerPoint that really represent that those two sides are parallel. So in this PowerPoint, you can see that the blue lines and the pink lines represent the same thing. But moving forwards, whenever you're representing parallel lines, please use the arrows like I've shown you in the pink example, rather than in the example that has been given to us by Twinkl. Now, sometimes you might get a quadrilateral or indeed another shape that has more than one pair of parallel lines. And it would be very difficult for you to mark them all with an arrow, because then somebody wouldn't necessarily know which pair it is that are parallel. So there is another way of showing more than one set of parallel lines like this. Here's a square. This is also a quadrilateral. It has got two horizontal lines that are parallel to one another, and it has two vertical lines that are parallel to one another. And you can see there that the first set of parallel lines have been marked with one line. They are a pair. They are the first pair of parallel lines. And then the second pair have been marked with two lines because they are the second pair of parallel lines. Now, that doesn't mean that the top line is parallel to one of the lines that goes down the side. They're not parallel at all. They cross over. You couldn't get a train running down those two lines. But they are parallel to their own partner. So you've got to make sure that you're looking at how many lines there are. We've got one set of parallel lines at the top and at the bottom, and then we've got the second set of parallel lines on either side of the shape. And again, they could also be shown by drawing arrows, just like I've done to the bottom shape there. So again, we've got one arrow showing a set of parallel lines going one way, and then we've got the second set have got two arrows showing those parallel lines going in the other direction. So parallel lines are fairly easy to understand, and you will probably be able to think of many other different types of shapes that will have at least one pair of parallel lines. If you look at some of the quadrilaterals that I've put onto the screen now, you will see some have only one pair of parallel lines. If you look at the top right, there's a quadrilateral there. That's a four-sided shape that has one pair of parallel lines. Then I've got three other shapes that you will see have got two pairs of parallel lines. We've got top left, a parallelogram. You can see where it gets its name from. The parallelogram has two sets of parallel lines. We've got a rectangle on the bottom left and we've got the square on the bottom right. Now we've also got a kite shape. The kite is in the middle. And you might be wondering why there are no lines marked onto that shape and whether I've missed them off or whether that's a mistake. It's not. The reason why there are no lines on that shape is because there are no parallel lines. Even if the lines look similar and they might look like they're moving in the same direction, if you were to extend that shape, eventually those lines would touch each other and they would cross. So they are not parallel. There are no parallel lines on the kite. And that's where having that labeling tool comes in handy. Now, the second piece of vocabulary that we're going to learn about today is the word perpendicular. Perpendicular lines. Now, perpendicular lines are two lines again, but these lines are lines which meet at a right angle. Now, that's really important. They have to form a right angle. In fact, when they cross over perfectly, they form four right angles. Now, two lines that cross over in any direction don't necessarily mean that they're perpendicular. It has to be crossing over at a point where you would be able to spot that it makes a right angle. And you can often show, as I showed you yesterday, that it is a right angle by drawing on those two small lines to make it look like there's that tiny box, there's that tiny square where those lines meet. Now, when you see that kind of symbol, you know that that is where two lines have met and they have created a right angle. Those lines are perpendicular. Here we have a square. So on a square, you have two sets of parallel lines, but you also have four right angles. So at four places, those lines meet and they are perpendicular to one another. They cross at a right angle. Now, we're going to be doing a bit more sorting today. A lot of the vocabulary you're still going to need from what we did yesterday, but I would also like you to start thinking about whether the shapes have got parallel or perpendicular lines today too. Now we'll start off by doing a really simple table. We've got here a set of shapes and we're going to organize them so that either in the quadrilateral section or not a quadrilateral in one of those two sections. So we'll start with the circle. Is the circle a quadrilateral? Does it have four sides? No, it doesn't. The next one up is a rectangle, the green rectangle. Is that a four-sided shape? Yes, it is. Then we've got the pink triangle. Now that looks to me like it's an equilateral triangle because all of the sides look equal, but it's not a quadrilateral. It's a triangle. I don't know why that's ended up so far out of the box down there. Now the next one is a five-sided shape. Well done if you can remember what name is given to five-sided shapes. It's a regular pentagon. That means that it's a pentagon, it's a five-sided shape, and all of the sides are the same, but it's not a quadrilateral. Then we've got a red square that has two sets of parallel lines, and actually it has four right angles, so lots of different lines that are perpendicular to each other as well. And it is a quadrilateral because it has four sides. We've got a kite shape. Oh, that should be in the quadrilateral section. I don't know why that's in the middle. That's definitely over on the quadrilateral side. Then we've got a trapezium. Again, is a quadrilateral. And then finally, last but not least, we have got a six-sided shape, which is a hexagon. And that hexagon is not a quadrilateral. So we've got four shapes that were not quadrilaterals, and we've got five shapes that are, one that's floating somewhere in the middle, but definitely needs to be over on the quadrilateral side. Now, these are a more complex type of diagram. They're similar to tables, but we call these Carroll diagrams. And you need to sort the shapes into the correct section by reading all four sections of the Carroll diagram. So we've got, again, we've split the table in half, and we're going to have the shapes in the quadrilateral side or not quadrilateral side, depending on whether they have four sides or not. But then we're also going to sort them again by reading lengthways, we've got then to sort out shapes that have parallel lines and then shapes that have no parallel lines. So we're gonna have to look at every shape individually and really understand the different properties and the different vocabulary that's associated with it. So looking first at the yellow shape, that's a five-sided shape, so it's a pentagon. So looking at the columns coming down first, it would be in the side that says not a quadrilateral. It would be over on that side. So that is not a quadrilateral. Now, it's either not a quadrilateral that has parallel lines, or it's not a quadrilateral and it has no parallel lines. Now, you might think that some of these lines do look like they're heading in similar directions, but actually there aren't any lines that are exactly parallel. So that would come under not a quadrilateral with no parallel lines. It needs to be all the way over in this bottom right-hand box here. It's not a quadrilateral and it has no parallel lines. Next up, we've got a rectangle. This purple rectangle is a quadrilateral because it has four sides. And it also does have parallel lines. In fact, it has two sets of parallel lines, two that are a bit longer and two that are a bit shorter. So that needs to go into this section here underneath quadrilateral and next to where it says parallel lines. Okay, next up, we've got a square, a blue square. Again, it's a quadrilateral because it has four sides. And we already know from the example earlier that squares do contain parallel lines. So that is going to go into the same section as the rectangle. And actually looking at those two shapes there, they do look quite similar. You might be able to spot the main difference between them, but they also share a lot of the same properties. Okay, next up, we've got an orange parallelogram. Now, parallelograms are quadrilaterals because they have 1, 2, 3, 4 sides and they have parallel lines. So actually, that's the third shape that's going into the same place on the diagram. There we go, another quadrilateral that also has parallel lines. And then finally, we've got the kite shape. You might remember the kite shape from earlier. It is a quadrilateral because it has four sides, but it doesn't have any parallel lines. So it's going to go onto the left-hand side of the table underneath where it says quadrilateral, but it can't go into the box next to parallel lines. It has to go in the box next to no parallel lines. So it's going to go right down there at the bottom left. There we go, we've sorted those shapes. Now, some shapes do share properties like the rectangle, the parallelogram, and the square, and they can end up in the same place on the diagram. Equally, you might have shapes that share some properties. They might share the fact that they are a quadrilateral, but they might differ on whether they have parallel lines or not. Now, one of my boxes was left completely empty. Can you think of a shape that is not a quadrilateral, but it does contain parallel lines? There's a challenge for you. What I would like you to do after watching this video is to have a go at the parallel and perpendicular line sheet that is below. And then we have got some shapes for you and some blank Carroll diagrams so that you can have a go at sorting the shapes however you want to. Now, when you're using your Carroll diagram, you need to make sure that on one side you've got this is true and on the other side it's not true. Otherwise, the Carroll diagram doesn't quite work. So it needs to be parallel lines and no parallel lines, and then quadrilateral or not a quadrilateral. You could also have is the color blue, is not the color blue, has three sides, doesn't have three sides. It needs to be either it does or it doesn't. Okay, so have a go at making some of your own Carroll diagrams afterwards, and I'd love to see the kinds of things that you have come up with. And I will speak to you all very soon. Bye bye.